Welcome. I am Professor J. N. Mandal, Department of Civil Engineering, Indian Institute of Technology, Bombay. Now, I will talk about the different apparatus and accessory required for the permeability test. Permeability mold having all its accessory and spare. Extraction and compaction device for static molding. Overhead water tank for maintaining the constant head stopwatch. Measuring the cylinder from measurement of discharge collected. Spatula, grease, oil, etc. Tray to mix the soil. This is the different types of the accessory required for the permeability test. So, this is the permeability, mold, and this is the extraction device from where the permeability sample are to be extracted using this equipment, and this is the overhead water tank. This is the tank, this the water is inside. So, this is overhead water tank, and this is the stopwatch. You have to measure at a particular time the flow of water through the soil, and this is the measuring cylinder, and this is the oil, and this one is the spatula. So, these are some of the equipment what you require for testing the permeability of the soil. This is the laboratory permeability test apparatus, and detail also are given here. This is the plug, and this is the gasket. This is the valve. This is the metal ring, and these are the mold. Mold is here, and it has a particular size, is 100 millimeter diameter and 1273 millimeter is the length, and this one is the cap, and this is the porous disc here, and this is the metal ring at the bottom, and this is the base plate, and this is the outlet valve, and this is the plug. So, all this drainage base also it is given here, and this is outlet valve. So, from this equipment we determine the coefficient of the permeability. This is the permeability test setup, and this is constant head permeability test. This one is the constant head permeability test, and this one is the variable head permeability test. So, we can perform the two kind of the test. One is the constant head permeability, and another is the variable head permeability. This is for the constant head permeability test, and this is for the variable head permeability test. So, you can use both the apparatus for the determination of the permeability of the soil. Now, let us talk about what will be the procedure for the constant head method. First of all, place the permeameter mold assembly in the bottom tank, and then connect the inflow to the constant level overhead tank with a suitable connection. Now, connect the overhead tank to a continuous water tap and connect the drain pipe of the overhead tank by a rubber tube and level the other end in a sink. Open the air vent of the top cap of the permeameter and allow the water to flow. Next, close the air valve when all the air has expelled from the cap. Allow sufficient time for the water to flow and saturate the soil sample and eliminate the entrapped air in the soil pores. When a constant flow has been established, measure the discharge in a given time. Then determine the head of water, then initial diameter of the mold and the height of the sample. And then you can calculate that what will be the coefficient of permeability of the soil. So, this is the equipment for the constant head permeability test apparatus. You can see here head, water head, this is the sample. So, here I can show you that this is the soil sample, this is the soil sample is here, and this is the constant head chamber, and this is the soil sample, its length is L, and this is the porous stone, the top, bottom, and this one is the rubber stopper, and this is water is supplying at a reservoir. This is the reservoir, and that is constant head. Water is supplying at a constant head, and then the water is overflow from here. So, this height from here to here is capital H, and length of the sample is the L. And then at a constant head, water can pass through the soil sample at a particular time, and then you have a here graduated jar. So, you can determine what will be the volume of water collected into this graduated jar at a particular time. Okay. Then from this you can calculate that what will be the coefficient of permeability of the soil. So, how to calculate this coefficient of permeability for constant head? Here I will show you the some calculation. To determine the coefficient of permeability. Now, we are discussing for constant head, for the constant head, okay, constant head permeability. Now, first of all, know what will be the coefficient of permeability. And that is designated at K, Q. K is equal to Q into L divided by A into H into T, where Q, this Q is the discharge of water. Discharge of water in cc. And L is the length of the sample. L is length of the mole and A is area of cross section. Area of cross section. And H is constant head. H is constant head. And then T is time, that is in second. So you should know that what will be the coefficient of permeability. That this is the equation for coefficient of permeability, that is K is equal to QL/AHT. Q is discharge of water in cc, L length of the mole, A area of cross section, H is equal to constant head, and T is equal to time in second. So from this equation you can calculate that coefficient of permeability. Now I can show you some specimen calculation for constant head test. Okay. So you know that molding density of sample is 1.823 gram per cc. So you have calculated that what will be the density of the sample. Then what will be the molding moisture? Let us say 21%. You know how to determine the density and also how to determine the moisture content of the sample. Then length of the mole, and let us say this designated at L is equal to 6 centimeter. And then diameter of mold is 7.98 centimeter. Next, volume of the mold. Volume of the mold is 300 cc. And next, area of cross section, and is designated at A is equal to 50 square centimeter. So we know that what is density, moisture, mold length, what is the diameter of the mold, and volume of the mold, and area of the cross section. So we know all this parameter. Now how to calculate the coefficient of permeability? Let us say one serial number. You are taking that constant head and that is H, that is centimeter. And then we have to what will be the quantity of water. that is Q in Cc. Then what should be the time required, that is T in second. And then you can calculate coefficient of permeability K meter square per second, and then you take the average K, that is meter square per second. So let us say this is serial number 1, and let us say that constant head is about 20.8 centimeter. And then you are measuring what will be the quantity of the water you are collecting here. So it passed to the, this is as a constant head, and let us say this head is about 20.8 centimeter, and water which passed through the soil sample, and then you collected here in this jar, okay, at a particular time, and then from this jar you will be knowing how much quantity of water you are collecting at a particular time. So let us say that quantity of water collected in this jar is about 36 cc, for a time, let us say in 30 seconds. Then from this you can calculate what will be the coefficient of permeability. Let us say that another experiment, this head is constant 20.8 and quantity of water, let us say 37 cc, and times second is equal to 30. And from these two data you can calculate what will be the coefficient of permeability for number 1 test, what will be the coefficient of permeability number 2 test, and then you can calculate the average coefficient of permeability. Now I will show you how you can calculate this K value. Okay. So this K value you can calculate using this equation. You know K is equal to Q into L, this divided by A into H into T. Now in serial number 1, what is Q? Q is equal to 36. Okay. So this is 36. This into what is the length of the sample? Length of the sample, I told you earlier, length of the sample is 6 centimeter. So this is 36 into 6. This divided by the area, cross section area. This area of cross section is 50. So this A will be equal to 50. This into what is the height of the sample. So height of this about 20, H is equal to, that is 20.8. This is 20.8. This is height is 20.8. So this will be 20.8. This into time T. So T required here, T required is 30. So this will be the 30. Okay. So if you calculate this, then you can have the 6.923 into 10 to the power minus 3 centimeter per second. So this is from the first serial number 1. You are having the coefficient of permeability, that is K, is equal to 6.293. So, we can write here that K value from serial number 1 is 6.923 into 10 to the power minus 5. Then from the serial number 2 test, we can write this quantity of water from second serial number is 37. So, this will be K will be equal to 37 into the length is the same, this is the 6, and this divided by area is also same, that is 50, this area is 50, and it is constant height, also second case 20.8. So, this will be 20.8 into that time required, time also 30, this time is, this is 30. So, if you calculate this, so you can have this value is equal to 7.115 into 10 to the power minus 3 centimeter per second. So, if you can convert it into meter, then it will be the 7.115 into 10 to the power minus 5 meter per second, and this also if you can convert, then this will be 6.923 into 10 to the power minus 5 meter per second. So, because here we have K, we mention in terms of meter per second. So, in the first test we are having that coefficient of permeability is 6.923 into 10 to the power minus 5, and the second serial, for the serial number 2, we are having that coefficient of permeability is 7.115 10 to the minus 5 meter per second. So, you can write 7.115 into 10 to the power minus 5 meter per second. Now, you take the average value of these two tests. So, you can have the average value 7.019 into 10 to the power minus 5 meter per second. So, you can calculate the coefficient of permeability of the soil, and this coefficient of permeability of this soil is 7.019 into 10 to the power minus 5. So, you know now how to calculate the coefficient of permeability of the soil. This for constant head permeability. So, constant head permeability of the soil can be determined using this constant head permeability apparatus. Because this permeability is very important for type of the soil, whether it is a coarser grain soil or the finer grain soil. So, one should know what will be the quantity of what will be the coefficient of permeability of the soil, and what will be the type of the flow of the soil. So, it may be the permeable soil, it may be the impermeable soil. So, if it is let us say gravel and sand, this coefficient of permeability will be on the hard side, whereas in case of the clay, coefficient of permeability on the lower side. So, it will almost act like a impermeable material. So, we so far discussed about the constant head permeability and how you can calculate the coefficient of permeability for the constant head permeameter. Now, we can discuss that variable head permeability. So, what are the procedure for the variable head permeability? We connect the permeometer to falling head standpipe, saturate the specimen, it may be 24 hours in case of sand. When a steady state of flow is established, then measure the head from the standpipe. After a known interval of time, measure the drop in water head. Compute the cross section of the standpipe as well as that of molded specimen. Then measure the height of the sample and then you calculate the coefficient of permeability. Now, this is the variable head permeability test. Okay. So, here I am just showing that this is the soil sample for variable head permeability, and this is the porous stone here, porous stone, and this is the rubber stopper, and these are the standpipe. This is standpipe, and because it is a variable head, so initial head here, that is, let us say H1, and then the final head from here to here is H2. So, this is H1 and this is H2. So, water can pass through this soil sample for the variable head, and you can calculate that what should be the coefficient of permeability for the variable head test. So, now I will show you that also how to calculate the variable head permeability test with this equipment, and next I will show how to calculate the coefficient of permeability for the variable head permeameter. Thank you.